Let me just open up the chat. Hey, everybody. Welcome to welcome to today's webinar. Really what we're going to be talking about is multi-agent systems. I'll throw some links in the chat where the GitHub repo is, so you actually can pay attention and focus or move along with it. Just super nice. But what we're going to focus on today is really building out a multi-agent system using all the open source tools from that we have from Solo. And let me just paste this in here if you give me 1 second. I'll just paste it in the chat itself. So what we'll cover is and hopefully you can, I am sharing my screen so you can see my screen here. If anybody can give me a thumbs up that my screen is shared, that'd be great. All right, perfect. So what we're going to cover is what are skills and how to build them, how to put them in probably a Git pipeline, share them across teams, and how some of the tools that we're going to be deploying and inside this Git repo has, how you use platforms like K-Agent, which is our Kubernetes native agent framework that really turns those skills and those agents into a declarative, composable agents. Because at the end, what we'll show is the big picture is how these skills fit into a full agentic stack with agent gateway, agent registry, and agent evals. So our full core, our full agentic stack is built inside this GitHub repo, inside this code, and we'll demo. But for today, I want to dive in on skills and how they're changing and the way you build agents. So really how I like to live through this is through a problem. And I start everything with a problem, right? We all had this. We all experienced an issue at 2 a.m. in the morning. And what did we do? We opened up a terminal. We executed kubectl, get pods, describe deployment, kubectl logs, right? And you, as an expert of doing this, you probably know those 5 commands and what order and how to run them because you've done this 100 times. But now that person sitting next to you, who's those save 5 commands, right? Maybe they just started. They don't know what they're talking about. They don't, have that experience with your infrastructure itself. So when we talk about infrastructure as code, but that expertise, that check events before logs because it's faster, or always do a dry run before applying, still lives in people's heads, right? And those heads can leave companies. People go and people move on. So we need to kind of figure out how we can use agents and skills to combine the knowledge of those people and be able to consume by other teams, right? Because we don't want to build a script, build an agent, build a skill. Like, we've done it bash scripts many years ago. And then we have another team B spends 3 weeks building something similar that team A did, right? We want to be able to share the concepts, and we want to be able to share the agents and the skills that are defined by those individuals of what the process is itself. So let's dive into kind of the concept of what is skill. So if we could capture that expertise of a skill in a format that's structured, that's portable, that's versionable, and testable, right? And that's really a skill. It's a structured markdown metadata at the top that says when to activate, what are the step-by-step instructions, that say how to execute and validate the criteria. That says, what looks good, what good looks like. And we have to look at kind of examples, or if we look at this example here on the right-hand side, we have Kubernetes or K8 health check skill. And this lists tools and procedures, gets resources, lists pods, describes unhealthy ones, checks events, and diagnoses rules, right? Pending plus, no events equals scheduling issues, or image pullback means check the registry, right? And this is something like a user, like for example, if we use Maria as a name, right? This isn't an SRE's brain or a senior SRE's brain that he's been doing this for many years, right? But we can change that, or we can convert that to really a file what we have skills. It's kind of this new unit of operational knowledge. So when someone says, or when someone's going to say, hey, we have a wiki page of this, right? Let me show you the difference, right? A wiki page says check the deployment status, right? Skill gives you the exact kubectl command in order with decision logic for each output. A wiki page, could have a static text, which could be outdated in weeks. A skill is version testable and executable. A wiki page also, nobody reads it at 2 in the morning. A skill, the agent reads it and follows it every single time, right? Exactly. So when an individual leaves, the wiki becomes this tribal knowledge that slowly rots, right? But the skills continue to live on because now every agent that reference it is going to get that expertise of that skill. So, and as we can see, even the bottom quote here is always check events before diving into logs, right? That's enabled into a skill. If pods are pending, check the node resources, not the deployment, right? That's the kind of knowledge that only exists in the individual's head that's built the infrastructure. So when we apply agents to it, we want to add those skills, right? Because until you put that in a skill, it's the agent's not aware of what it's going to do. It can hallucinate or do whatever it wants to really do. So let's get a little technical and kind of define the anatomy of a skill. A skill is a folder, right? The only requirement file is a skills.md, and that's the exact spelling name. You have to have it, capital skil.md. It's case sensitive, no variations, right? You can optionally add like scripts, / scripts, / references for documentation, assets for templates. But the key design principle is this progressive disclosure, a 3-level system that keeps things efficient, right? We have level 1 is that YAML.md file formatted at the top of the skills folder. And this is always loaded in the agent system prompt. And it's just a name, has a description, and the description usually is one line. You never split the description into multiple lines. A trigger condition, enough for the agent to know when to activate the skill without loading anything, right? The level 2 is the body of the skill MD. This gets loaded when the agent determines the skill is relevant to the current task, for instructions, processes, rules. Then we have level 3. This is the linked files or the script that references the assets. Only load on demand when the agent actually needs them. So this matters because the context window aren't infinite, right? And if we look at the math, say we have 20 skills or 18 skills loaded at level 1, which costs about 1,000 tokens, which is just the menu. And then we're loading all the 18 or 20 different skills at a full depth. That's over 3,000 or 30,000 tokens about, right? The progressive closure kind of gives us almost a 30 times reduction in token cost for skills that aren't relevant in the current task. Because there's that one skill, use that task. All right, that's 1,000 tokens, not to find all the tools in it, which could be 30,000 tokens itself. And it's not just about cost, because fewer tokens also means faster responses, less noise in the context window, and more focused agent behavior. Right? The agent is distracted by 19 irrelevant skills procedures. It only loads the one it needs, so it's very important to have that. And of course, if we talk about skills, we have to talk about MCP. Like MCP is the kitchen and skills are the recipe, in my mind, right? There's this mental model that I like to use of that is that MCP is a professional kitchen. It gives you tools, the ingredients, the equipment, access to your Kubernetes cluster, your monitoring stack, your ticketing system. But skills are the recipe. That's step-by-step instructions on how to use the kitchen tool to make something valuable itself. So without skills, you can connect your MCP server and the agent's access to, tons of tools, 30 tools, but you have no idea what order to call them or what to check first, or what the edge cases are, right? Support tickets asking, how do I X with your integration? And each conversation starts from scratch. With skills, the agent already knows the workflow, the consistent execution every time. So now, when we're writing these effective skill descriptions, it's critical that the format or the formatter that decides whether your skill gets activated at the right time. It's this formula of what it does, plus when to use it, plus its key capabilities, right? So a good example, if we're specific with trigger phrases, diagnose Kubernetes workload health. So when the user asks to check the pods, check the health check, or why my deployment is failing, right? So we want to be very specific in these triggers. A bad example is when a user says, "Hey, help me with Kubernetes," right? That's too vague, and the agent won't know when to activate it, and it'll either start firing on everything or nothing itself. So we want to be able to write very effective descriptions inside of our skills. And before you start writing these skills, it helps to know that, which way the two patterns that you're going to build. And I find there's two patterns of building skills. One is the problem first pattern or the tools first. The problem first pattern is the user walks in with a problem. Why is my deployment failing? The skill orchestrates the right MCP calls in the right sequence. The user describes the outcome they want. The skill handles the tool. And that's our Kubernetes health check skill. The users don't think about kubectl. They just describe the problem, and the skill knows the first 5 steps to to diagnose the sequence. When we focus on a tools first skill, the user already has the tools connected, right? Hey, I have a Kubernetes MCP server, right? You can ask it. The skill teaches optimal workflows and best practices that always dry run before apply, that check events before diving into logs, right? It's, that OMM killed, check the limit first, right? That's our, Kubernetes deploy skill. And it's encoding the best practices on top of the tools access the user already has. And right, so most skills lean really towards one direction. And knowing which framing fits your use case makes the instructions clear and the skill more focused. So if you're writing a problem first skill, lead with the outcome and the procedure. If you're writing a tools first skill, lead with the rules and the pattern itself. So skills, like we just said, they're just files, right? And they're files that can be stored in Git. They can also be in a container, right? Which allows them to be version controlled. So every change is tracked, every decision is reviewable, every PR workflow, that new skill gets reviewed like any other code change, right? It's shareable. You clone the repo, you use the skill, and a composable reference skills across repos and teams and organizations you can use. And this matters, especially when you're deploying this in some type of framework like K-Agent for agents, because it pulls the skill straight from Git, right? So in an init container, clones the repo, extracts that skills MD file, and mounts it to the agent's pod. So that same GitOps workflow your team already uses, right? There's no special tooling, no proprietary platform. Git is that distribution mechanism for this itself. So in the demo, we'll be using K-Agent. And if we talk about how skills become agents, well, now let's kind of dive in how these skills become those agents. So K-Agent is an open source a product. You can go to kagent.dev, and it is our Kubernetes native AI agent framework. And it has two modes. Really, it has this declarative mode. And this is what we're going to be using today, right? K-Agent handles the entire agent loop for you. You provide a system message, the tools, the skill, the models, and KAgent runs it, right? There's no code required. The skills gets pulled from your Git, injected into the system prompt. MCP2 tools are wired automatically through CRDs. Multi-agent composition within the type method is allowed, which is really just 4 lines of YAML. So it's perfect for for ops skills, diagnostics, coordinating skills, or coordination agents. So anything where skills is the logic. And then we also have the BYO framework, the bring your own framework. So bring your own container, bring your own agent code, like LangGraph, CrewAI, AutoGen, custom Python, whatever you're ready to build. KAgent handles that, and KAgent handles that Kubernetes lifecycle, right? So that deploy, the scale, the health check, the OTel tracing. You keep your framework, your agent loop, your logic, that same CRD, that same kubectl apply, the same observability itself. So this is for that bring your own framework. It's more for complex reasoning chains, right? For custom RAG pipelines, or when you have an exciting agent code base you want to run on a Kubernetes environment, you can deploy that on K. You can deploy that with KAgent. In both modes, are Kubernetes workloads. So the same tooling, the same workflows, the same clusters. You just choose the one that fits your use case itself. So when we're building out these agents, and here's kind of an example of what an agent looks like. This is a standard Kubernetes resource. So an API version, kind, you got metadata, and the spec says type. So the type is declarative. Then we have the system message that contains the full content of the skill. So when we apply this, right, the KAgent then creates a pod, pulls the skill from Git, injects it into the system prompt, and connects the MCP tools. And then the agent is running. That's simple, right? The 2 things to note is the kubectl apply.f is the same as a GitOps workflow that you already have. The skills instructions become the agent's expertise. And the agent doesn't just have access to the tools, it knows how to use them, right? So in what order and what decision logic, which is super important. So in the example, we're going to be building out, we're going to focus on 2 teams. We're going to be Team A and Team B. Team A is an SRE team that builds specific agents, that has health check agents, deploy agent, and Team B will be using this multi-agent system that will go in on how it's going to utilize the agents that Team A already used inside of the deployment, right? And here in practice, what it looks like to create an agent with YAML. You literally have kubectl apply -f health check agent, and then you can invoke what tools and what things you want to use and deploy inside this platform. And in this slide, I just want you to remember that when we are building out a multi-agent system, or when we're composing it, it's really as simple as creating the spec of tools and selecting the type, and we're going to select agent, and then we're going to add the multiple agents that are already in the system, right? So when we look at the YAML under tools, instead of a type of MCP server, we just write agent, and that points to another agent, and that's it. The health check agent and the deploy agent will be now part of, or now are the tools that the other agents can call. So allowing you to build this multi-agent system, right? And then skills are that, or skills captured that knowledge. So the agent executes it, that type agent composes them, and then it chooses which model to use. So from an multi-agent system isn't about complexity, it's just about composition, right? The first step is you build the specific skills, right? The health check uses the Kubernetes health check skill. A deploy agent uses the Kubernetes deploy skill, right? And we monitor the uses, right, through Prometheus query kind of skill tool. Then once we have those, step 2 is to compose the agents, right? Compose an orchestrator agent that attaches those agents to it. Because the flow is simple. The orchestrator at the top delegates to the specific agents below. And those agents talk to MCP tool servers at the bottom. So each layer does one thing very well. And this mirrors how teams really work, right? You don't have one person that does everything. You have specialists who collaborate, right? Itself. And the pattern is all in a YAML file. So in the end, when you're fighting incidents, right, of an error happening on an API server, what you'll do is once the error gets triggered or an alert gets triggered, the orchestrator agent gets involved. It calls the health check agent that's running those skills. It calls the health check, then comes back actually with node diagnostics. The orchestrator then calls the deploy agent to add nodes if it was CPU exhaustion, for example. And then the incident resolved, and every step is traced, evaluated, and audible. So the two teams contribute to this entire solution of solving, a specific incident flow. Team A builds those specialist agents and skills. Team B, the platform team, wires them together into an incident response agent, right? So Team B never needs to write a single kubectl command. They just compose what's already existed by those other platforms, by the Team A itself. Really then giving you a summary that kind of outputs something like this. And you'll see this in the demo. Uh, so why don't we dive into the demo and then we'll talk about what skill gives you. Actually, let's go through this because the demo will be pretty quick. So the key things that the demo will show you and what skills gives you is um, this knowledge outlines of what people have done, right? So if an individual left, right, her diagnostic experience runs inside every agent that you can build that references the skill. So a new hire doesn't need to spend months learning the agent. It already knows it, right? The agent already knows what to do. That consistent execution. It's always the same process every time, no drift, no shortcuts, no, I forgot the steps, no hallucinations, because you have the skill that identifies it. Then you could also use tools like Agent Eval to evaluate those skills. So eventually, as you move this into production, you're going to use tools to evaluate how that agent, how the skill is working. And you can score that inside the platform. Then you're going to have separations of concerns. The skill authors are the domain expertise, the SREs, the networking team, the security folks, right? The agent builders and the platform engineers, right? They both contribute, yet neither need to understand others' domain, which is perfect. Then, of course, testable and audible. Skills define expected tool sequences, right? You can evaluate whether agents follow them. And really that's possible with I told the LLM to be helpful. Like those are the kind of words you can, say like it's not possible where when you can just write or prompt your LLM, hey, be more helpful. You're still wasting a lot of tokens, you're wasting a lot of time, right? Fewer tokens could equal better results, right? Remember progressive disclosure, right? It pays off here. Without a skill, a typical task takes 15 back and forth messages and burns, let's say, 12,000 tokens. The user explains the workflow step by step with a skill, two clarifying questions, and then we have 6,000 tokens, half the tokens. Better output, it's faster, it's cheaper, and the agent isn't guessing the workflow. It already knows the workflow that you provided to it. Right. And before the demo, I just want to share 5 more patterns that work well across different use cases. We have sequential workflows. So multi-step process is a specific order. That's in our demo, we have our Kubernetes health check. We do get resources, we describe, we do events, logs. Each step depends on the previous one. If we have multi-MCP or multi-MCP coordination, workflows spanning multiple services, right? We diagnose in Kubernetes, we create a ticket in Jira, we notify in Slack or Teams. We have a clear phase separation with validations between each phase. Then we have this iterative, oh, iterate, my goodness, I can't even say it. This iterative refinement, right? The output Quality improves with loops, right? You got to generate a draft, run quality checks. You got to fix issues. You got to revalidate, repeat until the threshold is met. Then we have context-aware tool selection, right? Same goal, different tools depending on the context. Pod is pending, question mark, right? Check the nodes versus checking the scheduling constraint, right? The skill has the decision logic for each scenario. And then, of course, domain-specific intelligence, right? This is a big one. Like your skill adds knowledge beyond what tool access alone provides, right? Yeah, compliance checks before the action, uh, 8 years of SRE expertise encoded into an executable process. And this is the pattern that, we can build with like a Kubernetes skills uses, right? This is the one that makes the biggest difference is building out those domain specific intelligence. Right. And before the demo, let me save you kind of some debugging time because these are the four mistakes that, everyone makes when building their first skill. And it's important to understand skills never triggers, right? Your description is too vague. Help with projects. That won't match anything. The description is the first level of progressive disclosure. It is how the agent decides whether to load your skill. It needs to be specific and include trigger phrases users would actually say. Like compare help with Kubernetes versus diagnose Kubernetes workload health. All right? So we got to use when users ask to check pods or why is my pod failing? Like that's how descriptive we want to be. All right. Skills triggers, too often. The opposite problem, right? Your description is too broad and fires every Kubernetes question. A negative trigger, right? Right. Do not use a sample data exploration. Use data with skills instead. Tell the agent what skills it's not for. Then, of course, we have instructions that are not followed. Agents load your skills, but skip critical steps. Usually, this means your instructions are too verbose, right? Or the important parts are buried in paragraphs. Use bullet points. Put critical infrastructure at the top. Use headers like critical, important. Be specific. Instead of validate the data before processing, say critical. Before apply, verify dry run passes. Resource limits are set. Readiness probe is defined itself. And also slow and degrade responses. Your skill MD file, if it's too large, you may have too many skills enabled simultaneously. Keep skills under 5,000 words, right? Move detailed documentation to the reference folders. If you have 20 plus skills enabled, consider skill packs, right? Group related skills to only relevant ones itself. And only debugging tips that work every time, right? Ask the agent, when would you use the health check skill, right? It will quote the description back to you if it's missing something, right? Interview it. It tells you exactly what to do. So let's jump into this demo. And inside this Git repo, it's pretty easy to run this on your laptop or your machine. I'm running this in a kind cluster, so no cloud, no magic. And I'm actually deploying 4 different open source tools from Solo itself. So let me just open up the terminal. So I have the platform deployed. I can go kubectl, get pods. I have everything kind of deployed and I have the GUI access to it. The first thing I do have is our agent registry, which I've deployed. There's already 2 agents running itself. And as you can see, it's pretty basic. It's pretty simple. There's nothing in here, but this gives me the capability, and we'll see, to add MCP servers, skills, agents, prompts into the platform, and then be able to deploy it in a Kubernetes environment. So for this instance, I already have 2 agents deployed and 2 MCP servers already pushed to my Kubernetes the environment itself. So if I log into my K agent, you can see I have 2 agents deployed. They're running GPT 5.4 mini. I have my models, which is my default model. I'm just using ChatGPT 5.4 mini. that everything's configured to. Everything is proxied through Agent Gateway in this aspect. And everything then is also logged to an OTel collector, which then sends all my agent logs to Agent Eval, which allows me to evaluate the health and the session of my live agent so that I can create an evaluation set and build a gold standard of how my agent, my skills are acting in here. So just to make sure everything works here, I'm just going to click on my agent. As you can see, we have the chat history on the left-hand side and all the tools on the right-hand side. I'm just going to minimize this and expand this, and I'm just going to ask it, what can you do? So this is going to make a request towards the LLM. It's going to look at its instructions, its system prompts, and it's going to give me an output of what can it do. Hey, I can diagnose pods, deployment services, etc. In here, and I can interact with it, and I have a full session of the actual conversations that are happening with this agent and my LLM. And of course, if I go to the edits section here, you can see the type that we talked about, the description. You can see the agent instructions on what the agent's supposed to do. You have other things like modeling. You can enable LLM reasoning, select the tools or the agents that are deployed, select embedding memory, context management, and of course, skills on the bottom here. So let's dive into this demo. Let me open up my terminal. And here's what we're going to do. So in this instance, we already have the environment deployed. So the first thing we're going to do is we're going to build the skills for our health check agent. So we want to build that health check and that deploy agent itself. So let's open up my terminal. So I just want to verify that Agent Gateway is running. So I do have Agent Gateway running. All right, perfect. We have AI Gateway running in here. Agent Gateway is our proxy that we're proxying all our LLM and MCP traffic to. The gateway, it's a gateway resource, a standard Kubernetes gateway API. So with an OpenAI backend, so every LLM call from our agents will follow through this gateway, right? No direct calls to OpenAI. This allows us to add guardrails, add any permissions, be able to log the data, alter the prompts, and whatever we want. So the goal here is that the SRE team captures their expertise as a skill and builds specific agents, right? So we have Team A, we're going to be building a skill, and I already have the skills built out so you can take a look at them. But the skill is to know Kubernetes cold, right? They're tired of being the only ones who care or who can diagnose a failing deployment. So they want to write down the exact ways on how they triage an incident, and not this wavy or hand wavy version, like the exact steps, and they want to turn this into a skill. So I'm just going to show you this skill here that I've deployed. So this skill is a structured markdown, like we said. It says, here are the tools to use, right? Here are the get resources, get describe, get pods. Here's the sequence that we want you to do to check everything we want. So check the pods first, then the condition, then the events, then the logs. If something looks wrong, right, here's how the format should be reported. Yeah, 100%. Let me paste it in again. Here it is. Oops, wrong one. That's the repo. So this is, the brain of that SRE agent or that skill, right? That senior SRE that, they've been doing this for so many years. They've built this skill that, always check events before diving into logs. And if the pods are pending, check the node resources, not the deployment, right? That knowledge is now in a file that talks about it, the structure of it, how the report should look like. How do I want to process the report? Resource, status, pods, issues, severity, evidence, the fix, validation criteria. And I even have an example of how I want the output to look like and the expected tool sequences to use here.
So, and this is key. The this is the key thing. This skill is portable, right? It's not buried in one agent's config. It's not locked to one team. Anybody can use this skill. So now once we have this skill, we need to build the agent. So let me just scroll up here. Here's the YAML file for the agent, right? The agent pulls its skills straight from Git. So I'm hosting the skill in Git because it's centralized, it's controlled. So when kagent deploys this agent, an init container clones the repo, extracts the skill MD, and mounts it to the pod. The skill lives in Git, it's versions, it's tagged, it's reviewable, and that same GitOps workflow your team has always used or using, right? And inside here, after the skill, because we're using a declarative approach, we have the default model. So I'm just using that ChatGPT, which is configured in kagent as my default model. We have a system message, short and sweet, your mission, the critical rules, the health check procedures that we have, and what tools you're able to use. So inside kagent, you can actually also apply an approval tool that you can create a human in the loop for some of these tools. So if you don't want them to execute a specific command, you can add a human in the loop in here. So, so what we're going to do next is deploy this agent. So I have a script running. I'm not going to deploy all the agents at once. It's just easier because it shows some nice output. But everything, like I mentioned, it's proxied through. If I go up here, it's proxied through my agent gateway. So I'm just doing some pre-flight checks, making sure that the model is okay, making sure that the tool servers are deployed, um, what agents I'm using. So I'm deploying this agent. I'm using a Go runtime because it's super fast. I'm using the health check agent, and I'm deploying this via just the API for the script. And then I can literally do a curl statement towards my kagent and ask it, hey, um, check the health of, oops, that was so quick. Check the health of all the pods in the namespace. And then boom, I get a response right away. From the agent of what it's running and the output. So the same thing that I do if I go to kagent and I refresh my screen, I have those agents deployed. So if I go to edit, I can see all my information about my agent, and I could literally ask it, and you can see it because I made a curl statement, it's already had that conversation. So I could start a new conversation and go literally the same thing. Hey, what is the health of all my pods? And as you can see, the first thing it doesn't grab all the tools or all the tools that it's here. It says, hey, I need to just get resources. I don't need to go deploy logs, events, describe. I need one thing to be able to solve that problem or solve the question and the answer. And then it gets the um, get resources, gives me the results, and outputs everything how I want it to output based on my skill and my description in my agent, right? There's no evidence of anything. This pod is running perfectly, right? So, which is great. So now using um, using just Kubernetes and using a declarative way, we have two agents. We have a deploy agent and a health check agent, right? And if we take a look at this deploy agent, it has 6 different tools, and this deploy agent even has requires approval before execution. So if I want to delete a resource, right, it's going to ask me for approval before I do it. So the agent won't just go wildly and start deleting things. I can have that human in the loop in here, right? So what we'll do is I'm just going to deploy an Nginx demo inside this config. And like I said, all the steps are in my repo. So I'm just going to make a simple deployment of Agent X in a pod with 3 replicas running in my environment. So now that it's deployed, I can go back to my health check agent Start a new chat. And I just say, hey, check the health of my Nginx demo. And see, watch what happens. It's doing exactly what our plan told it to do. Here's the output. It grabbed the resources, grabbed the events, and it gave me all the information I need. Um, because we get the pods, we describe the deployment, we check the events, and it does that in 10 seconds. And the output is structured. There's no Python, there's no pip, no CLI. The agent runs this inside the cluster because that SRE's experience is running 24/7, not just, when that individual's on a call, we have that agent of her expertise in a skill and an agent together, right? And every one of those LLM calls that flows through Agent Gateway, right? We didn't configure anything specific for the agent. The model config just points to the Agent Gateway that routes to OpenAI, which makes that governance, observability really in a one-line config. And that's it. Like now, this is great for Team A, but what about everybody else? So Team A can now start consuming this agent and using it. But how about we share this across people, right? And what we want to do is Team A now can register their skill and other teams can discover them, right? This is where the registry comes in itself. So let's just go to catalog. We have nothing here registered. We just have what's deployed. But what we can do is now register things inside the platform. So Team A has those working agents. Let me clear this. But right now they live in Git. They're in a repo that only Team A knows about. And the platform team might not have access to the repo, or the team doesn't know they exist. So the networking team can spend 2, 3 weeks building their own really health check automation tool without nobody knowing or nobody telling them other stuff exists. Right. And this is familiar. We've had this problem with Helm chart problem all over again, right? Before like an artifactory or an artifact hub, everyone was copying, pasting charts from random repos. So we solved this with agent registry, right? It's the same thing where we're taking those skills, those agents, and deploying them. So what team A is going to do, and I'm just going to execute the script, but it's just a bunch of commands where Team A registers everything that it's deployed. So it's going to register the skills, the agents, those MCP servers itself, right? And even the gateway itself, it can, right? You can make just a simple API call like I'm doing here, or a command, or a Git repo can push this. That has versioning, right? Just like pushing a container image to a repository, right? And notice automatically those skills, if we just refresh the page, those servers, those skills, those agent are now registered into the repo. Then we have a deploy button here that we can then deploy it to whatever Kubernetes cluster that we want. We can take a look at the skills and we can see that, hey, here's linked to the repo. Here's kind of the raw information, all the metadata that we want around that skill set. And here's even the agents that they deployed that we could use and go ahead and deploy them into whatever Kubernetes environment, namespace, set the environment variables for those deployments I want, right? Itself. So when someone tries to find the skill in the catalog, they can do it. They can even use CTL commands. They can curl the platform itself. Because this is agent registry. And think of it like that artifacts hub for AI, right? And right now we have what? 2 skills, 2 agents, 2 MCP servers all deployed itself. So now we have this catalog, and this is how Team B is going to find this. They're going to log into the agent registry catalog, and they're going to take what was already built, right? Right. This is the payoff. All right. Team B never touches kubectl. They find what exists and they wire it together, right? So if we switch hats, and now we're Team B, we're the platform team, not the SRE team, and we've been asked to build an incident response for automation, right? We don't know Kubernetes that well or at the same level as Team A does, but we don't want to, right? We just want to use what they've already have. There already existed skills and there existed agents. So the first thing we do is we search this catalog that we have this, and we can we have those Kubernetes skills available. We have the deployment. We have the health check from it. We have everything version documented and battle tested itself. Right. The neat thing is Team B doesn't need to understand those resources that it uses. Doesn't need to understand Kubernetes resources. They didn't need to know the diagnostic sequences, that SRE team to build this into the health check skills. They just need to know how this agent can diagnose and this agent can deploy. So Team B can now build an orchestrator. So let's take a look at the orchestrator here. Let me just clear this. So Team B can build a new agent and call it incident response agent. It'll be a declarative agent. It's going to have a description. It's going to pick the skills that it's using. So we're going to use an incident skills because we've built our own incident skills around this, that how we want the output to look like itself. We specify the system message, our mission, our goals, how we want the output to look like. And then at the bottom here, we specify the multi-agents that we're going to use. Team A created this Kubernetes agent for deployment, and they created a health check agent. Exactly what we're going to do. We're going to use those agents. And TB's agents don't need to know those commands. They just say, hey, use those agents, use the skills that are deployed when anything is required. So what we're going to do is we're going to register this skill, or let's deploy this agent. And I just have a command just to do it quickly for us. So now the agents are deployed. We can see that we have 3 skills, 3 agents, 3 servers. So if we refresh our agents page, we have that incident response skill that was written by the Team B team. We have its agent that was built in Go in a declarative way, so we didn't even care to look at the Go. And if we go to our deployment, we can see that it automatically already deployed that incident agent. So we can go into K-agent, refresh our page, and now we have an incident agent that Team B can run and be able to do whatever they need to do with it. So let's just log into this agent. And this agent or orchestrator agent itself now has tools and agents on the right-hand side. It has a Kubernetes deployment agent, and it has a health check agent. So when we make a call, right, if we're seeing an error inside the instance, like if we're seeing an error 503 inside the Nginx demo namespace, investigate it and produce an incident summary. What we're going to see is that K-agent or our agent orchestrator is actually going to make a call to the health check agent and it's going to get the output. Then it's going to make another call to the deployment agent, right? It's delegating the tasks of what it needs to do to those different agents that Team A built because they're the ones that built it. And it's going to give us the output how we want to see it because based on our skill and our agent, it's going to use all the information we've provided in the skill and how we want that root cause analysis, how we want the information processed and what actions need to be taken and what's the status of this investigation itself, right? So really this allows us now to utilize this agentic framework, let's say, or an AI framework of a registry, an agent eval, K agents to deploy agents, share our skills, our agents and tools across to other teams, and then also evaluate the tools using things like agent eval, where we can see, our eval sets get published or our tool sets get published to the platform where we can evaluate the response of those agents and those skills and then rate that type of evaluation in this really multi-agent system itself. Because the key thing is that, we've got those agents to work. We shared those skills, that multi-agent composition, everything looks great, all right, in this demo. Um, we want to make sure that when we're building these agents and tools, right, you're scoring them, you're evaluating them, you're testing them itself because it's super important uh, to be able to build something successfully. And for you to build something successfully uh, and not for it to start hallucinating, you have to apply these skills in really a production-like manner. You can't just be building them on your device itself. So please take a look at this repo. Try this out yourself. Feel free to connect with me however you'd like through LinkedIn or X or Twitter itself. But the one thing I want to say from a takeaway or four things to remember um, when we're building out these skills is sorry, uh, is skills are really are like the new unit of operational knowledge. Itself, right? No run books, no wiki pages. They're executable, they're versionable, they're composable, they're Git native, which is amazing. Agents that are declarative and are Kubernetes native, run CRDs. Once again, they follow this GitOps process. The skill is the power or skills power that messaging system or that system message. And then using multi-agent system, right, to compose orchestrators or taking, the best practices of an agent from another team is super important because it's super easy to build and add. And then skills also make knowledge that outlives people, right? The SREs who built it leave, the skill is stayed, right? You have that documentation and every team benefits, especially as you register those layers inside the platform itself. So uh, skills make the agents more knowledgeable on the processes that you have inside your platform itself. So with that, I'd just like to thank everybody. I almost took the whole hour here to talk about it. Everything you saw here today ran in my Kubernetes cluster on Kind. It was all open source using, K-agent, agent gateway, agent registry, and agent eval itself. Skills are first. Declarative agents, building multi-agent compositions within the platform is super great. So hopefully you enjoyed this. If you did, share it with a friend, and looking forward to the next one. Thank you.